Hi everyone, my name is Ms. Kinner, and I just wanted to take a moment to introduce myself before I switch my computer to tablet mode to write on it for the rest of this screencast. So today's screencast is about naming compounds that contain polyatomic ions. Why are those important or relevant? One example is calcium carbonate. So, calcium carbonate is a compound with a polyatomic ion that used to be the main ingredient in chalk. Most chalk is actually gypsum now, and so it's usually made with calcium sulfate, but that's another compound that contains a polyatomic ion. So, these are really common in our everyday life.
We're going to talk about naming with polyatomic ions today, but first let's just look at ions of elements right on the periodic table. What about when sodium likes to form an ion? Its most common ion charge on our table here is found at the top right-hand side of the column. It says the common charge of the ion. And so for sodium, it most commonly forms positive +1 ions. Calcium, on the other hand, its common ion charge is 2 plus when it forms an ion. If we go to some of the nonmetals that gain electrons to form negative ions, chlorine will gain 1 electron and become a -1. An oxygen atom, its most common ion charge is a 2-, so it most commonly gains 2 electrons to form a 2- ion. So these are their most common ion charges of elements. And so we would call these compounds things like sodium chloride and calcium oxide. How do we come up with the chloride and the oxide? Well, if we look at those elements, for example, carbon, we just cut it off at the carb and call it a carbide ion. Nitrogen, we just cut off at the nitra and call it a nitride ion. We don't call it nitrogide, for example. Oxygen, we just take the ox and call it the oxide ion. We wouldn't call it oxygenide. Fluorine, we call fluoride. Phosphorus, we call phosphide. So we call it the sulfide ion, the chloride ion, selenide, and bromide. So we're kind of chopping off that name a bit for the ion name, an iodide. So we're taking these highlighted roots and adding IDE to the end to get the ion name. So for example, take the highlighted brom and add ide, dropping the INE. Take the highlighted nitra and go ahead and add ide, nitride. Take the highlighted sulf, skip the UR and add IDE, and we get the sulfide ion.